Hello everyone, and welcome to this second video in rationalizing the denominator with surds. Now we're coming on to more complex questions in this lesson, and let's have a look at question 12. So we've got now, you'll notice we've got a surd, but we've also got like a plus or a minus in there as well. So let's have a look at question 12a. So we've got 1 over root 2 plus 1. Okay, 1 over root 2 plus 1. Now, in order to rationalize these type of expressions, we need to multiply by something that's referred to as the conjugate. Okay, and the way that that works is whatever this sign is, you change it. So in this case, we've got positive, so we're going to change that into a negative. So we have got root 2 minus 1 and root 2 minus 1. Remember, in order to keep the value of the fraction the same, we need to multiply the numerator and the denominator by the same value. Okay, so we're timesing the numerator and the denominator by the same value, which in this case is root 2 minus 1. So in the numerator, we have 1 times root 2 minus 1, which is root 2 minus 1. And in the denominator, we're going to multiply this double bracket. So if we think about how that's actually going to work, let's have a look at it. So we have got root 2 times root 2 is 2. And we have got root 2 times minus 1 is minus root 2. We have got plus 1 times root 2 is plus root 2. And then finally, plus 1 times minus 1 is minus 1. So now, when we collect like terms, we have plus root 2 and minus root 2 cancelling out with each other. And the numerator is still root 2 minus 1. The denominator is now 2 minus 1, which is 1. So in this case, the rationalized fraction is root 2 minus 1. And we have rationalized the denominator. In this case, actually remove the denominator altogether. So that's an example of how we would approach these kind of ones. Let's move on and look at an intermediate level one of this kind of example. So perhaps if we were to try question 15a. So question 15a, let's have a look at this one. So we have got here root 2 over root 2 plus root 6. So in this question, we're going to be multiplying the numerator and the denominator by root 2 minus 6. So we're going to multiply by root 2 minus root 6 rather. And we're going to multiply by root 2 minus root 6. Okay, so let's think about what this one's going to look like. So the numerator is going to be root 2 times root 2 is going to be 2. Root 2 times by minus root 6 is going to be, I'll write that as minus root 12 for now, because 2 times 6 is 12. I'll come back and deal with that root 12 in just a moment. Let's have a look at the denominator. Root 2 times root 2 is 2. Root 2 times minus root 6 is minus root 12. Root 6 times root 2 is positive root 12. And then finally, root 6 times minus root 6 is minus 6. Okay, now that's an area there where students often make a mistake. Let's examine that more closely. A positive times a negative is a negative, and root 6 times root 6 is 6. Okay, so you can see again that now we have a pair of numbers that are going to cancel out with each other. And in the denominator, I have 2 minus 6. So that's going to be minus 4. Let's now consider the numerator. We've got root 12, and if you remember from before, root 12 can be thought of as being root 4 times by root 3, which is in turn 2 root 3. So I'm going to write that as 2 root 3. Now, at this point, we can simplify this fraction a little bit more because we have a common factor of 2. So every term can be divided by 2. So that's going to give us 1 minus 1 root 3 over minus 2. So that's it partially simplified. However, it's considered to be somewhat sort of inelegant to have a negative number in the denominator. So we are going to multiply the numerator and denominator again by -1 in order to get it into the most acceptable form. So -1 times 1 is -1. Minus √3 times -1 is positive √3. And then -2 times -1 is 2. So, and again, it's not customary to necessarily start it off with a negative number. So I'm going to write that as √3 minus 1 all over 2. Okay, and this is the kind of thing where, you know, you wouldn't lose marks. Let's say I'd left it like this. You wouldn't lose marks unless the question said write it in its simplest form, in which case you would have lost a mark if you didn't simplify it. But I'd be very hard pressed to imagine that you would lose a mark if you left it like this. This is just an aesthetic thing, just to get rid of the -2 in the denominator. The only time that I think you would be penalised in this case is if you were told that you were aiming for a particular thing. Show that it can be written like this, and then you didn't. Okay, that's the only time I think you would be losing a mark there. Okay, so that's how you deal with it when you've got more complex ones. And let's just do one more that's quite complex and got a lot more involved in, a little bit more involved in. Let's have a look at question 15H. Okay, so question 15H. In this one, we have 3√7 minus 2 all over 2√7 minus 5. I'm going to multiply the numerator and the denominator here by 2√7 plus 5. Notice I've changed the sign from minus. And notice that I'm also multiplying the numerator and the denominator by the same thing in order to preserve the value of the fraction. And I'm going to just here, just as is my wont, do 2 little grids in order to multiply these. So I'm going to have here 2√7 add 5, and here I've got 3√7 minus 2. So I've just written that multiplication as a grid there. Here I'm going to write this one. So I've got 2√7 add 5, and this is times by 2√7 minus 5. Okay, let's start off with this one over here. So we have got 3 times 2 is 6, √7 times √7 is 7, and 6 times 7 is 42. So 42 goes there. 3√7 times 5 is plus 15 √7. And minus 2 times minus 2√7 is minus 4 √7. And then finally, minus 2 times 5 is minus 10. So when I collect like terms, 42 take away 10 is 32. And minus 4 √7 add 15 √7 is plus 11 √7. So that's the numerator expanded out. Let's look at the denominator now. 2√7 times 2√7. 2 times 2 is 4. √7 times √7 is 7. And 4 times 7 is going to be 28. 2√7 times 5 is plus 10 √7. And minus 5 times 2√7 is minus 10 √7. And as you can see, they are going to cancel out. Minus 5 times plus 5 is minus 25. And when I collect like terms, 28 take away 25 is positive 3. So that means that my numerator is 32 add 11 √7, and my denominator is, in this case, 3. So I've written that in that way there. You might sometimes see it written slightly differently. For example, it could be written like this. And this is just a different way of writing the same thing. So I could write that as 1/3 times that. This has the same meaning as this expression here. Okay, well, that's looking at rationalizing the denominator for expressions that are involving surds, and we've got all the way up there to questions that are a little bit more complex. Just as a little extension challenge, so if I was to write here extension, there's always ways that they're looking to put an extra kind of spin on these, and I seem to remember quite a poignant sort of GCSE question recently that was of this type. So let's imagine that we had our 3√7 plus 6, and let's say it was over our 2√7, but let's say it was minus 10. And this is what the question was, I seem to remember. Now, in an expression like this, because they're always sort of trying to, you know, separate students from one from another, the common temptation, I think, would be to expand this whole thing by 2√7 add 10, and just to times the whole thing by 2√7 add 10. And that would be incorrect. Okay, the correct approach with this kind of expression would be to expand the brackets first. Okay, so we would need to do 3√7 add 6 times by 3√7 add 6, 2√7 minus 10 times by 2√7 minus 10, work all of those out and get a new expression. And it would then be that new expression that we would multiply by the conjugate. And the conjugate is the fancy maths name for when you change the sign here. Okay, so if you get something like that, you would just be just take note that you would need to expand that whole thing first, work out what it is, write down the new expression, and then proceed. Okay, and you know, anybody who fancies, you might fancy having a go at that just to see what how that works out. Okay, thank you.